This video will show how to run external scripts through the command line in VisualFoundation. Let's get started. In addition to using the command line directly, as shown in the previous video, more complex scripts can be generated in any text file and read into the program. This allows models with complex geometry to be created, finite element meshes to be automatically refined, parametric studies to be performed, and much more. Note, when developing external scripts to be ran in VisualFoundation, any valid C# code can be used along with the commands that are already built into the program. The help file contains a number of example scripts to help us get started running external scripts. So let's launch the help file and navigate to the external scripts page. We will start out by looking at the combined footing example. This example uses an external script to build, load, and extract results from the same exact model discussed in the script command line training video, where we created, loaded, and extracted results from the model using the command line directly. Let's copy the code to the clipboard, paste it into a text file, and save the file. Now we can type browse into the command line, navigate to the file we created, and open it. Next, we see that VisualFoundation prompts us to select the concrete type for the pier since the pick concrete command was used in the script. After selecting the concrete, the rest of the model is generated and the loads are applied. Finally, once the analysis is complete, the results are extracted and printed in the command line. Next, let's look at the model and loads example script. This script builds a slab and grade beam system that is supported by piles. The model is loaded by 4 column piers, and by uniform slab load, and by line loads on the perimeter grade beams. This is a good example of how to build and load a model from a text-based file format. Having already saved this script in a text file, let's load it into the program by simply entering the path in the command line. Now we see the model is generated and loaded automatically. One advantage of using scripts is that we can easily change the parameters in the script to create a similar model that, for example, has a larger footprint. After adjusting the parameter, we can save the script file and read it back into the program. Now we see the larger model that is generated using the external script. Now let's look at the refined mesh example script. This script builds a simple model with a square slab and pier. It then loads the pier and sets the mesh for the project to an element count of 100. The script then refines the mesh around the pier until the moment at the face of the pier converges. The mesh refinement is achieved by using the refine pier command, where the element length at the start and the element length at the end are reduced by a factor of 0.7 per each iteration. Note, inside the while loop in the script, the await analysis command is used to pause the script until the analysis completes so that the moment at the face of the wall can be obtained to compare with the moment from the previous iteration. The model is considered to converge when the change in the moment is less than 0.05 kip inches. Having already saved this script in the text file, let's load it into the program by entering the path in the command line. Now we see that the mesh of the slab gets successively finer at the pier as the script iterates towards the converged solution. Finally, we see that the moment in the slab converges to negative 2.36 kip inches. The final difference between the moment and its previous iteration delta is less than 0.03 kip inches, and it took 6 tries before the model converged. Finally, we'll look at the optimized bearing example script. This script builds a model with a circular slab that has a radius of 12 inches. A pier is then added to the model and loaded with a dead and live axial load. A while loop is then used to add 1 inch of radius to the footing until the soil bearing check passes. Note, the await design command is used to pause the script until the design completes so that the status of the bearing check can be determined. Having already saved the script in a text file, let's load it into the program by entering the path in the command line. Now we see the size of the slab progressively increases and the soil bearing unity check progressively decreases until the unity is less than 1.0 and the check passes. The script displays in the command line that a final radius of 19 inches was required for the slab for the bearing check to pass. In just a few minutes, we have used the command line to run external scripts to build a combined footing, to generate a slab and grade beam system that is supported by piles, to refine a mesh to convergence, and to optimize the size of a footing. These examples just scratch the surface of what can be done with external scripts in VisualFoundation. We hope you find this new powerful feature useful and it increases your productivity in the program. Thanks for watching and have a great day.